Maximum subarray. Given an integer array, nums, find the subarray with the largest sum and return its sum. So we want to find the largest sum of a contiguous subarray in the array. If an array was, let's say, 1, for example, like it is over here, then the number we return is 1. Over here, if it's all of the numbers together, we want to return 23. So, right, 5 plus 4 is 9, minus 1 is 8, plus 7 is 15, plus 8 is 23. So the subarray can be the entire array itself. And keep in mind, we're not returning any left or right pointers or any indices. We're just returning the largest number, the largest sum of a contiguous subarray in the array. Let's take a look at this array here. So if we were going to solve this in our minds, we might just look for the largest numbers, positive numbers close together, and then add them together. So 4 plus -1 plus 2 plus 1 gives us 6. So this right here, this gives us 6. And then we might look over here and say, okay, well, this gives us -4. This over here on the right gives us -1. And we don't want to add a negative number to our positive sum. So we found our number. We found our sum. The highest sum of this array is 6. But if we were going to solve this with a program, how would we do it? Well, what we can use is we can use a loop. So we can use a while loop or for loop to solve this. We'll have two variables that we keep track of, apart from I. We'll have a left prefix, which is this, and we'll have a highest value. We'll set both of those equal to the first value in the array. And then we'll check, does the left prefix, which is -2, is it less than 0? Right? If it's less than 0, no negative number added to any other number is going to make it a larger number, right? If the number, let's say, is positive, like in this case it's 1, that's going to equal -1. And if the number was negative, let's say it was another -2, that's going to equal -4. In both case scenarios, this negative number is not making our sum greater. It's making it a lower number, a more negative number. So in that case, if the number, our left prefix, is negative, we don't even want it. We want to completely disregard it and set our new left prefix equal to I plus 1. So I is 0 currently here. We're comparing our left prefix to I plus 1. If our left prefix is negative, we will set our left prefix equal to I plus 1. So we'll set it equal to 1. Then we'll check, hey, is our left prefix greater than our highest value? Yes, it is. So we'll set our highest value equal to 1. Then, so we've removed this -2, right? Or we just have completely disregarded it, and now we're moving on. Now we've iterated I by 1. I is over here, and we will check I plus 1. So we will be looking at -3. Is our left prefix negative? No, it is not. It's equal to 1, which is not negative. So then in that case, all we will do is we will add 1 to -3 to 1. So 1 plus -3 is equal to -2. So our left prefix now equals -2. Our highest value is greater than -2, so we won't change it. And then we'll iterate on I. So I becomes -3. We are checking I plus 1, which is 4. So is 4, first off, is our left prefix negative? Yes. Off the bat, it's negative. So immediately we're going to set our left prefix equal to I plus 1, which is 4. We've completely now disregarded everything to the left. And then we check, is 4 greater than 1? Is our left prefix greater than our highest value? Yes, 4 is greater than 1. So we will set our highest value at 4. Then we'll go through again, we'll increment I. I is now 4, and we're checking I plus 1. So is our prefix 4, is that a negative number? No, it is not. So we just add -1 to 4, giving us 3. Is our left prefix greater than our highest value? It is not, so we'll keep our highest value at 4, and then we will increment I. So now I is over here at -1, and we're checking I plus 1. The value of I plus 1 is 2. Is our left prefix greater than 0? Yes, it is, so we'll just add I plus 1 to it, giving us 5. Is our left prefix higher than our highest value? Yes, it is, so we'll update that to be 5, and then we'll increment I. I now equals 2. We're checking I plus 1. A value of I plus 1 is 1. Is our left prefix negative? No, it is not. It's equal to 5. So we will then add 1, or I plus 1, which equals 1, to our left prefix, which gives us 6. Now we check, is our left prefix greater than our highest value? Yes. We update our highest value to equal our left prefix value, and then we increment I. So notice that every time on each iteration of our loop, we are doing 2 checks. We're saying, is our left prefix negative? If so, replace it with the value of I plus 1. And then a second check, is our left prefix greater than our highest value? If so, set the highest value equal to the value of the left prefix. So I is now at 1, and we're going to check our left prefix, compare it to I plus 1, which is -5. And we say, well, is our left prefix negative? No, it is not. So we'll simply add -5 to it. 6 plus -5 is 1. Then we check, is our left prefix greater than our highest value? It is not. So we increment I and move on. Now I is equal to -5. We compare I plus 1 to our left prefix. Our left prefix is not negative, so we'll simply add our left prefix. We'll add our left prefix to I plus 1's value, which equals 5. So it brings us back up to 5, which is a positive number, and it's a pretty big number, but notice how it's not bigger than our highest value. So on that second check, 6 is greater than 5, and therefore we'll keep 6 as our highest value. These commas, this isn't to indicate that highest value is an array. It's only one number, but these are just the numbers it was at different iterations of the loop. So at the end, we find that our highest value is 6. We did not keep track of the fact that it was these indices, or we would have to keep track of that, right, if we needed to return that from this function. But since we're only returning the highest value, these are the only variables that we have to track. So let's jump into the code editor and solve this in both JavaScript and Python. The first thing we'll do is create our variables. So let left prefix equal nums at 0. Let highest value, we'll call it highest val, also equals nums at 0. And then I equals 0. Then we'll open up a while loop. While I is less than nums.length minus 1. And the reason we have the -1 here is because as we iterate through this array, we're going to look at I plus 1. So we don't want to ever exceed the bounds of the array. Therefore, we are always going to iterate through as long as I is less than nums.length minus 1. First thing we want to do is check if the left prefix is less than 0. If the left prefix is less than 0, we want to set it equal to nums at I plus 1. Else, we want to set the left prefix equal to itself plus nums at I plus 1. So that would be plus equals nums at I plus 1. And then we want to do our second logical check, which is to see if the left prefix is greater than, the highest val. And if it is greater than the highest val, what we want to do is set the highest val equal to the left prefix. Then lastly, what we want to do is I++. We want to increment I by 1 at the end of each loop. And then we want to return highest val out of this function. And we can actually, given that there's only one line of code in each of these if-else statements, we can actually just keep them all in the same line to make it look nice. We can remove the open and closing brackets, and this is how our code can look. All right, let's go ahead and submit this. If left prefix is less than 0, left prefix equals num plus 1. Left prex is not defined. Oh, left prefix. I spelled this incorrectly. Okay, great. Let's go ahead and solve this in Python. So the first thing we're going to do is set our variables. Left prefix, so left underscore prefix. And then we've got max, or actually highest underscore value, and I. And we'll set those equal to nums at 0, and 0 respectively. Then what we want to do is open up a while loop. So while I is less than the length of our nums array minus 1. So while I is less than the length of nums minus 1, we will check two things. So on each iteration, we want to check if the left prefix is less than 0. And if it's less than 0, what we want to do is set it equal to nums at I plus 1. So left prefix equals nums at I plus 1. And if left prefix is greater than, if it's equal to or greater than 0, what we'll do is we'll set left prefix, so else left prefix is equal to left prefix plus nums at I plus 1. And another way of saying this is left prefix plus equals nums at I plus 1. Our second logical check that we want to do on each iteration is we want to check if the left prefix is greater than the highest value. And if it is, what we want to do is we want to set the highest value equal to the left prefix. So highest value equals left prefix. There we go. So at the end of the while loop, what we want to do is iterate I. So we'll say I plus equals 1, which will iterate by I by 1, and or increment I by 1. And then after the while loop, we want to return the highest val. Okay. So let's go ahead and run this to make sure it works. Awesome. I forgot to mention this in the conceptual part of the video. The time complexity of this solution is O of n, and the space complexity is O of 1. The time complexity is O of n because we have a while loop here, and the relationship of the time the while loop will take grows linearly with the size of the input array. And the space complexity is O of 1 because we have these 3 values here, these 3 variables, and their memory does not increase based on the size of the input array. So their memory will stay constant. And that is how to solve maximum subarray.